Hi everyone, thanks for joining us. I'm Joe from Installer, and this is the first of our series of Drayton Forums. We've put together an expert panel of engineers to discuss the hottest industry topics. So first up, we're looking at how to improve the efficiency of existing systems. So I'll introduce you to the guys. Now, if we start with Richard. Richard, can you tell us a bit about yourself and your kind of role and your background, please?
Yeah, I'm Richard Burrows. I'm the director at 𝗵𝗲 Plumbing Heating Supplies. I'm a heating engineer for 20 years, run my own online shops and have a trade counter in Mid Wales. My background is in advanced heating systems, system design, and I also do training as well. And at the moment, we're doing a load of installer training days, things like that, and just trying to get the standards up in the industry, just ready for low carbon technologies and low temperature heating.
Perfect. Next up, we've got Ryan Mills. Ryan, what's your role and your company, please?
So I'm Ryan Mills. I'm based up in Edinburgh. Work with my dad. He started the business almost 40 years ago now. I started in 2005, just general plumbing and heating work. You'd much rather the heating side of it. I am the 4th generation plumber within the family as well, so it runs through our blood. And I've got a 3-year-old boy, so he's still a bit early, but I'll soon have him trained up and get him under the floors. But yeah,
that's my fifth generation coming soon.
He's coming soon.
Next up, Bradley Beswick. Bradley, can you tell us a bit about your role and your company and things, please?
Yeah, we're based in North Wales. I work for 𝗵𝗲 Plumbing and Heating and Renewables. We do quite a lot of like eco schemes, and we subcontract British Gas as well. Recently, we've just been doing lots of upgrades of like from old systems to new systems, from open vented to combi boilers, all you can think of really.
Yeah, brilliant. And finally, Jonathan Scholes. Jonathan, can you tell us a bit about your background and your role, please?
Yeah, I'm based in Coventry in the Midlands. I'm new to the heating industry. Started my apprenticeship last year, so I'm in the 1st year now. I work with my dad. My dad's had his business for around 40 years as well. So yeah, I'm looking to take over from him in the long run and move across into renewables more than likely with the future. But at the moment, we're just doing anything gas, plumbing, heating, basically all the different things. So yeah, so I'm just learning every day, really.
No, but it's quite a kind of interesting time for the industry. So it's good to have a kind of broad range of what you guys have done, and Jonathan as well, coming at it from a new entry to the market. So big question to kick off with: are customers concerned about rising costs? Should we start with Ryan? In your kind of experience, we hear a lot about it in the news and things like that. Is this something that is more in customers' minds than it was maybe 18 months, 2 years ago?
Well, I would certainly say in definitely the last 4 months, 4 to 6 months, you find easily half of the customers I'm going to now are asking, should I be getting away from gas? What's the future? What's this? What's that? What do you reckon? Now, if it's me personally, I think I'll be retired and we'll still be fitting gas boilers.
Really?
Oh yeah, it's not going anywhere yet, particularly where I'm based. Up in Edinburgh, buildings that are hundreds of years old, they're not set up for renewable technology. And when you have the council saying you can't put in double glazed windows because it's affecting the character of the building, I feel like the little steps need to be taken before we can start taking the big steps, where someone needs to have a bit of common sense and think, hang on a minute, if we're telling somebody they should go down this route, be more efficient, maybe we should start with basics, as in double glazed windows, things like that. You know what I mean? And I don't know how the infrastructure would cope in a city like Edinburgh, for instance, that's where I am, of taking everybody off gas. Because at some stage, whether it goes to hydrogen or whatnot, there's a huge area you're going to have to say, right, as of this date, your gas is off and you're going hydrogen like that. I don't know how that is possibly going to be able to happen. And the fact, certainly the area I'm in, just outside Edinburgh, Midlothian, I think it's the fastest growing for new build, certainly in Scotland, but I think it was UK. They're all getting gas boilers. So if they're trying to tell us 2030, 2040, whatever it is, why is it going on now still? You know what I mean? I think new builds should be no gas, and they should be set up for the future. And when it comes to the older stuff, the small steps should be taken, as in insulating the buildings better, double glazed windows, etc., etc.
Yeah, Richard, what were your thoughts on that? Because obviously you working a lot with using existing products to make systems more efficient as well, and then obviously into the heat pumps and things like that as well. So what were your thoughts when Ryan says he still reckons he'll be fitting gas in his career? What were your thoughts?
It's changing fast, isn't it? So last few years, you know, I mean, I live predominantly in a gas and oil area myself, so it's we in Mid Wales, we're very similar to Ryan's area. A lot of people, you know, haven't got, you know, not got the expendable amounts of cash, things like that, but you know, always lots and lots and lots we can always do on these systems just to you know, make them as good as we can get them. You know, I mean, if we look at things like new build properties, for instance, they're not suitable for gas boilers. You know, there's a lot of you know, you see it all the time, don't you? In London, you see a lot of flats, you know, with combi boilers in, 24 kilowatt combi boilers in a flat with probably 2-3 kilowatts of space heating demand. You know, and nowhere, you know, yes, they got hot water, but nowhere near 24 kilowatts. So there's a lot of places now that just not suitable for gas boiler technology anyway. So, you know, but we're still fighting against, you know, government and policymakers, you know, try and iron out this whole efficiency thing, and try and actually get some suitable technology put in. You know, and that's not necessarily heat pumps either. That could be, you know, a range of things. A lot of technologies coming onto the market at the moment. You know, a lot of energy storage products, off tariff products, lots of stuff coming onto the market that, you know, we need to start thinking about. You know, what maybe heating and hot water as separate entities. Do you know what I mean? Because at the moment, it's very easy to go and put a combi boiler in a property, and you know, you've covered both space heating and hot water demand, but is that the most efficient way of doing it? Is it? I don't know. Some places I'd say not, but certainly, you know, existing buildings, there's lots of scope to improve things. Controls are a big thing. I know lots of guys out there right now, you know, they are fitting manufacturers' controls, you know, starting to get on the load compensation if they haven't already been on it. You know, lots of people out there have been doing the load compensation and weather compensation thing for a long time, but you know, let's face it, there's lots of properties out there that can have a full retrofit with controls, and it, you know, we could be reducing flow temps, things like that. We could be saving quite a lot of money in those buildings and just improving that efficiency just that bit more. There was actually a fact the other day which, if everyone actually in the UK managed to get their flow temperatures down to sort of in the condensing range rather than outside the condensing range, we could actually save enough gas in the UK that we wouldn't have to import so much, you know, from places like Russia and places out there like that. So, do you know what I mean? We you know, there's big scope in what we can do as heating installers, designers, you know, and manufacturers at the moment to actually try and improve everything that's going on. But you know, let's face it, gas boilers are going to have been our sort of stable bread and butter for a long time, and a lot of installers will go for gas or oil before considering other things. And that's not just installers, that's actually what the consumers, you know, or what the consumers used to want, you know. But I'm finding that attitude is changing. You know, a lot of people asking for different technologies now, you know, and people becoming aware of their carbon footprints, what they're actually doing and how they want things to go. But, you know, right now we're at a turning point, I think. But, you know, like I said, lots we can do, but lots of things that need to be done as well.
Yeah, Bradley, what's your kind of experience? Are you finding that people are paying more attention to their heating systems? What kind of advice do you have if people ask? What's your experience there?
Well, we get asked quite a lot, what do we think the future is going to be? But it is a very, unanswered question. No one really knows, because there's, like you say, there's so much coming out. There's so many new things happening. But we've done quite a lot of work on stone buildings and stuff like that. And, some people have had air source heat pumps in there, and they've not really done that much because there's not insulated as well as it probably should be. We, like, there's quite a lot of, just like you say, new things coming out, and it's all a miss. No one actually knows. And like you say, the gas boilers are, they are bread and butter, and it is what everyone's sticking to at the minute.
Yeah, I mean, I think there's still 1.8 million boilers going in a year, I think, for the figures.
Yeah,
from
well,
last year.
something for me as well is, so there's a well-known boiler manufacturer that I use all the time, and they've got a new model coming out, I believe, in a few months. So that, for me, tells you something as well of what the long-term sort of picture really is. Why are companies investing so much money in gas boilers when apparently it's going to be gone? And like Bradley was saying, there's stone buildings. Everything up here in Edinburgh, stone buildings, no cavities, wall insulation, single pane windows, which are 2.5 meters high, 3 meters, 1.5 meters wide, some of them, absolute monstrous rings. And you're not allowed to do anything to the outside front of the building. It's difficult to even do anything at the backs. It's where all the drainage, everything runs. You're not going to, let's say, air source heat pumps, you're not going to be able to strap that to the side of the building. It's just not going to be allowed. You can't, even where I stay, do ground source because it's mining towns, so there's nowhere to go with that. You can certainly do air source in some of the houses round about me, but it's a huge investment for people. A lot of people look at it that way, and you say to them, well, you're now talking radiators, you're now talking pipework. Yeah, just put in a gas boiler. And that's unfortunately where I think it's the new build has to be hammered now. We shouldn't still be fitting gas boilers in new builds. That has to change. But in the existing, it's going to be a long, long, long way off before anything can change. And it's also, a lot of the properties, there isn't the space. There really just isn't the space to be accommodating a lot of stuff required. And it's a big thing. People are going to start sacrificing rooms to accommodate what's required. Like I can see Richard, obviously that's a bigger scaled house, but there's a
don't
it's a one bed flat.
Yeah.
But there's a lot going on there, and a lot of customers also don't want all that. You put a cylinder in a cupboard and it's too much for them. So there's a lot of coming and going to be had.
Jonathan, what was your kind of, because you mentioned earlier that you're coming into the kind of industry, and you said I'll probably be fitting renewables more than I will be gas. So what was your kind of thoughts and the thoughts of the people on your course and things like that?
I'd say that as a hope. I'd say I hope we'd be fitting more renewables because that's the way the government are pushing on going. But like listening to people, what you say, everyone said here, all makes sense, and I can pretty much vouch that's pretty much exactly what our customers have said. A lot of the houses in Coventry are 1900s big. They've got cavities under the floors. You wouldn't, air source wouldn't work. A lot of the houses at Coventry is quite compact as well. So where are you going to do ground source? People aren't going to be at, most gardens haven't got access to the back gardens anyway. So how are you going to be putting ground source heat pumps in these places? Understand things like that. So it's a new technology. Well, it's got to be some kind of technology's got to move. Manufacturers have got to change. Like like you said with the gas boilers are coming out. There's still always new boilers coming out. They're always bringing out new boilers. And like I said, the manufacturers are the first ones that have got to change. Until they start changing, why are we, as the installers and the customers, they're not going to change either. Customers, I heard someone the other day, one of my friends does a lot more commercial work. He had a school that he had to fit. Their company quoted for a gas boiler change, and it was 60 grand. The school couldn't get funding for that because of where they were. They had to have a certain amount of renewables. So they went air source, and I think it cost them somewhere in the region of 160 to 180 grand or something like that. And you're talking, that's a ridiculous amount of money. And where are people aren't going to find that from any, like our average customer isn't going to find that. We have found that a lot of our customers are asking how to reduce their gas prices. So we are seeing that a lot more. So I feel like people's awareness, obviously gas prices have risen through the roof, so everyone's become more aware of their gas prices, how much they're using their gas. So we have found a lot more customers are asking how to reduce their gas bills and stuff like that. But then as soon as we talk about lowering their temperatures and stuff like that, or how they use their heating, it's still very, very outdated. And trying to, okay, the newer generation of customers, the younger generation, are a lot easier to tell them about controls. So we do fit a lot more Wiser nowadays. A lot of people ask me about Wiser and how that would help them in their house. But so you've got all these modern controls that will help, but a lot of younger people, but the older people, our older customers, they're interested in that the room thermostat on the wall where they can turn it and instantly see a change. They want to see the whole house getting warm, not just the room they're using. So it's a massive education shift from the bottom, or the top, all the way from the bottom to the top. Like, everyone needs to change, and it's who makes that change first, really.
Yeah, concentrating on like you mentioned, as things that we've got now, and Richard mentioned it as well. But are you saying to your customers, if they say, how can I reduce my bill, or I'm worried about my bill going up, are they more interested in things like controls and TRVs and balancing? Is that like a conversation that's easier to have now?
Definitely controls, cleaning systems massively. We go into so many houses that have got radiators 30, 40 years old, or 20, 30 years old, no filters on the systems. So just the amount of, like, the 9 out of 10 houses you go into, unless they're existing customers, if we're going into new customers, they've got a very, very outdated system, and it's coming from cleaning the system out can help. Getting more heat out the rads, changing the radiators. The radiators are a lot more efficient nowadays. There's education to be had everywhere, and it depends. You've got to kind of think, depending on your customers, which avenue you kind of talk about. So some people we can talk about controls and they're not interested, and then others we can talk about whole system upgrades and stuff like that, and they'll be interested. So you've got to take each customer for what they are, really.
Yeah, right. What about you? Are you seeing that kind of trend with people maybe more willing to invest in things like controls and things like that because the payback's a bit more, or because you can start seeing things go down quite quickly?
Yeah, well, it's amazing how many houses out there still don't have thermostatic radiator valves. That's a big one that people are getting more on board with and understand. I always try and use load compensating controls, but like Jonathan says, there are a lot of old people, and even not old people literally just want to put in the heat and then put their hand on the radiator and be like, "That's piping hot, great." That is the sad thing is that's what they want. The first thing they will look for is putting the heat and they want the place red hot. And they'll think about probably what it's costing and stuff afterwards. And obviously, I'm sure it's going to come to all of us. The older generation need the heat, so it's like I go on my granny's. It's like a furnace, So heating's on 24 hours a day. Thermostat's up at 25 degrees, and it's absolutely cooking. And you can say to these people like my granny, "Oh, I'll put in load compensating controls." She doesn't go have a clue. It's just going to be a nightmare, and you're just going to get called continually. So this is where it's even difficult there. When I go back to takes small steps can you make a big difference. Like, make sure there's not excessive pipe runs. Make sure it's well insulated. Like John says, radiators. The radiators going back 40 years, they're definitely a better quality. The steel is solid, but they're not convecting heat. They're just big lumps.
How many people
hot water, basically?
How many people put their settees or their beds right up against radiators? Just
also, when you say to people as well, a radiator is 40-year-old and it's like 1800 long, which is not required. You say to them, "This will also go to decorate the room." Yeah, no, we'll just leave it. And this is a battle that you're up against, you know, trying to tell people. But, you know, so I always say to people when they've got that sort of case, I say, well, if you come to decorate this room, get that radiator changed, because that's the time to get it done. But you think you're seeing the end of it, and then you go into a house and you think, oh my god, this boiler's like 50-year-old, the controls are so basic, but it's amazing how much is still out there. But like a job I just done the other day, pipework coiled under the floor because the previous install obviously couldn't be bothered cutting it to length, no insulation, nothing, you know. So small steps I think can make a big difference. I don't think we need to necessarily be like, whoa, pump the brakes, we all need to go onto air source and stuff like that. I think that's definitely the way things are going, but for me now, even the next 10 years, it's still early days. So I can remember solar being talked about 15 years ago, and it was solar's the big one. We're doing solar. Valent solar's what I fitted. Valent have now stepped away and went, well, we're kind of done with that. So, you know, where's you know, if solar was a big thing 15 years ago, and one of the manufacturers now saying, yeah, we're kind of finished with that. It's not really worked the way we wanted. I'm not saying that's going to happen with the next batch of stuff, but you never know.
Richard, go back to the controls, because obviously this is kind of your area of expertise. When people do say, you know, like people want their rads red hot, you know, they don't understand the heating systems, they're chucking, you know, sofas in front of it. What's your kind of advice to get around these sort of barriers?
It's a difficult one, isn't it? Because you know, I mean, the big thing is it's all well and good us, because obviously we've been on a few things, Joe, and we've been on a couple of interesting training things recently, and you know, that's the classroom stuff and what's achievable, and you know, with controls and what, you know, degassing systems, making sure we got the air out of the systems, that increases efficiency of heating systems, you know. But it's a mile away from actually what the real life is. You know, when you go out, there's no insulation on any of the pipework under the floors. Like Ryan said, pipe were just called up just for the sake of it, just because someone couldn't be bothered to cut it down or whatever. You know what I mean? It's just extremes of stuff, really, isn't it? But when you come back to controls, I mean, the big thing that always been for me is, you know, if we can just, I mean, if you go from a on-off clicky stat, right? So if we talk about little basic measures we can all do, okay? We go from an on-off clicky stat on the wall. If we can just get that changed to a TPI thermostat, 2-wire TPI battery operated thermostat, Drayton do them. You know, if you can get away from clicky stat to that, we can probably save about 8%, right? That's the fact, okay? And the reason we save 8% is because we stop the overshoots. So even with a clicky stat with a neutral and an anticipator within it, it will still overshoot. You know, we're going to go about 1.5 degrees over our set point, and we get that sort of cycle, okay? If we can get rid of that cycle, so we just swap a clicky stat out for a TPI thermostat, we can stop that peak and trough, okay, and we can save about 8%. Okay, if we can get away then from that TPI, it's very hard because, like Ryan said, some people won't have it that their radiators are not boiling hot anymore. But if we can get education out there and get the, you know, I'm not saying for everyone, but if we can get people onto low compensation thermostats, you know, there's extra gains again. It's about another 5% again on top of the 8 already saved with the TPI control. So that's what's possible. Getting that into real life is a bigger thing, because people are resistant. But I think as energy prices go up, I think people are going to actually start to want to listen a bit more than, you know, previous, because it's all well and good having a boiling hot house and rooms that you're not even in running away with themselves. But the reality is, once that start, if we double gas price, for instance, and people go up from £1,000 to £2,000 a year on their energy bills, people are going to want to do something. So that's when, you know, systems like what, you know, Drayton Balancing Key, multi-zone TRVs, they're really great just for the, you know, on gas and oil in particular. With heat pumps, we've got to be a little bit careful because we need that minimum volume of water in the circuits. But with gas and oil boilers, if they've got half decent modulation ratios, we can shave those rooms that we're not occupying right down, just heat the rooms we're in, and try and save as much that way. I mean, it's a tough one. I mean, I've been on a lot of projects. I've worked with councils, and did all the research up in Salford. That was my last big thing, and all the research backs it. So changing those controls out, getting rid of class 1 would be a massive step for manufacturers if they were to get rid of class 1 controls out of their portfolio straight away. If we don't allow the house builders to have the minimum required controls, so get rid of the class 1s, we'll already be on a kind of a winner, isn't it? Do you know what I mean? If you can take that, save 8%, that's a big deal straight away without then reducing flow temperatures. Everything else we can, designing the system for 55 degrees, that's going to be a massive thing in the new Part L building regulations. A 55 degree flow temperature mandate, that's gonna really change things. But obviously, that needs to be backed up with digital benchmark, making sure installers are commissioning the systems correctly and designing them for that flow temperature. Because if they're not, then it doesn't all work, does it? We've all got to do our kind of best and all and our parts the way we can. Otherwise it all falls apart. But first instance, consumers need education around controls. Second instance, installers shouldn't be afraid to try and do the best they can, because sometimes it's easier just to go with the customer, give them what they want and walk away. But I think there's got to become that point of a mutual agreement that, you've got to, if you're really interested in saving, you talk to your customer and say, look, if you're really interested in saving money, these are the things you've got to do, and this is what your expectations should be. If you don't want to do that, that's fine, but you're going to carry on with your high energy bills. That's the fact. So the reality is there's money to be, there's money to be saved. There's energy to be saved. It's whether, the consumers, want that, but they will. They will double the gas price or triple the gas price or all prices or whatever happen. It's inevitable.
Yeah, buddy, what's your kind of experience when you talk about these kind of measures with customers, especially like Richard said, gas prices have gone up. They probably will go up again at the end of the year. Are they like more open to it, less open to it? Are they more difficult? Do they need a lot more hand holding? What's your experience?
Yeah, well, we've had people say obviously like gas prices are rising, and they are continuously rising, and more than likely probably to still keep rising. But like you say, it's every engineers shouldn't be scared to fit as best as they can. But then when you've got a good engineer who's got a bigger price than someone who probably will just whack a combi boiler in, who's the customer probably is just going to pick someone who's not going to do as good of a job, because not many people are probably going to want to spend that amount of money on someone who's going to probably they're going to fit the better job, but the customer doesn't really have the education to know that. And it's like you say with the education with the controls, it's exactly the same as if something costs 3 times more than the clicky on and off one, then people are probably just going to pick that one because it's a lot cheaper. But it's like you say, they're going to save on the gas, but then it's like they're going to have to pay for that straight away. They're going to have to pay for the controls, the fitting, the boiler, everything straight away, instead of paying their monthly bill for the gas, where they'll probably not notice it as much as paying a couple of £1,000 straight out the bank into the plumbing. But it's one of them. It's very hit and miss. I think a lot of the good engineers might not have as much work as maybe some of the bad engineers, if that makes any sense.
Yeah, it's interesting. Richard, you mentioned it again. You mentioned it earlier, but we'll touch on this again because this is something that we've been seeing a lot of as well. Just turning down the flow temp on the boiler to reduce bills. Could you just talk me through that as an idea, and why you think that people should do it, and why it's such a simple thing that could save a lot of people energy bills?
So condensing gas boilers, they don't condense until the heat exchangers at about 54 degrees Celsius. So So when we design, or traditionally when we design heating systems, we used to design them for like 70, 75 degrees. So this is going back. I remember doing my energy efficiency, which I don't know if everyone remembers, but when condensing boilers came out, sort of 2003, they were then mandated, sort of 2005. Yes, they were available before that, but pretty much the UK had to sit the City and Guilds energy efficiency qualification just to say that we're okay fitting condensing boilers. One of the issues, they kind of touched over it. So I mean, I remember doing the training at 𝗵𝗲_𝘁𝗶𝗴, and they made it clear that, yeah, condensing boilers needed 54 degrees, to condense, but they didn't really say that. They kind of mentioned it was like 54 degrees around the return temperatures, but they didn't go too much into it, and I don't think any other manufacturers did really either. But the reality is, what happened is that we carried on just fitting, we were used to standard efficiency systems. So we used to just carry on designing the flow temperatures and the radiator and emitter sizes for like 75-degree flow temperature. And then not many installers balance that. That's a reality. Okay. So what would happen is you'd have a boiler. The combi boilers of early doors, so early condensing combi boilers, used to have fixed pump speeds before the ERP pumps came out. So what that meant then is that the flow rates would just absolutely hammer through the heating systems. So heating systems were then really difficult to balance as well. So we would have a boiler with a flow temperature of 75, and the return temperature coming back to the boiler would be very similar. It'd be sort of 65 degrees. So we'd only really shave 10 degrees off our flow and return temperatures. But coming back at 65 meant the boilers are out of condensing mode. And because we weren't fitting load compensation controls as well, and very few weather comp systems. I mean, I did a few weather comp systems when I was fitting combi boilers back then and system boilers, but very few and far between. And what happened is, obviously the flow temperature on the boiler stayed up at 75. So flow out, return back, boiler never condensed once in its life, apart from the initial startup, getting it up to 75. But after that, it would go out of condensing mode. So just turning that flow temperature down just brings it back into condensing mode. So what also happened at the same time as sort of the condensing boilers came out is properties got insulated. So there was big schemes in place to insulate the properties, which then meant actually the radiators that were fitted there originally for the original heat losses of the property, actually they're now oversized. So where they might have been designed for like a 75-degree flow temp, you can now probably get 60-degree flow temp into them, and they'd still heat the property just as well and still up to the correct room temperatures. So the turning the flow temperature down, it's been a big campaign by several people now, including Joe at the Heating Hub and myself. But 𝗵𝗲_𝘁𝗶𝗴 Energy got behind it, quite a few people. There's thousands of retweets over all of the sum of the campaigns that have gone on. Michael did it. Michael Walsh, he got behind it. There's loads of people who did it then as well. But it's just kind of rolling on. But literally just turning down that condensing boiler, getting it into condensing mode, it's about an 8% saving straight away. So just recovering that extra energy that would normally go out the flue, just putting that back into the central heating system instead of letting it go outside, it's 8%. So if we can get flow temperatures down to about 60 degrees, return temperatures back below the mark, ideally they need to come back at sort of 45, 40 degrees to have that sort of effect. But the lower we can go, the better. That's why weather compensation systems are just so good, because that does that automatically depending on the outside air temperature. When we've got fixed output TPI stats or on-off clicky stats, the problem is that the flow temperature on the boiler is fixed output, and it's normally left wanged up, or like Ryan said, customer wants really hot radiators, chucks it up to 80 degrees, just ruins everything you ever tried to do. Even if you balance it, they've ruined it instantly. Do you know what I mean? And it's just getting that right. If we can do it, it's brilliant, because there's a load of energy just being wasted to atmosphere that we can recover. But it's just getting the attitude behind the people out there, making sure that they're behind it as well. But all you need to do, look on Twitter, look on a few other platforms, you can see the amount of people that have got behind it and have done it, chuck the advice out to their friends, they've done it. Everyone's willing to save a bit of money, especially as the energy prices are going up. It's well worth doing. But if you can design it in initially, even better, isn't it? So if we can design the system initially in bigger rads, if we can do it, and just get that flow temperature down. If we can do design for, it's not legislated yet, but if we can get it down to 55-degree flows, we're already in condensing mode. So anything coming back then is going to be below that 54-degree, mark, and all the better, mate. What more can I say?
Yeah. So, Ryan, would that work with your customers if you went in and kind of advised them to do this, or if you just did it and didn't tell them? Is that something that you think would work, or what?
No, see, I definitely set up to do that and balance systems, and everything's all set up properly, but I can only then leave it in the customer's hands as to how they want it. And unfortunately, a lot of people will touch the radiators and say, oh, I want it hotter than that. You think, no, well, this is the most efficient way. It is going to heat the room. Everything's going to work. But they're just touching that radiator. They're just thinking, I can keep my hand on that. And a lot of customers now, they're certainly getting better. If I explain what I'm going to do thoroughly, they do get on board with it. Now, as Bradley was saying, a lot of, unfortunately, will just think of price. And you have to be careful too when you're self-employed that if you try and do them, you'll always look to do the best. But if you go in every time and just say, this is a full repipe, this is this, that, you're probably not going to win that much realistically, because you're going to get 3 other guys coming at the back of you and say, you just need to change a boiler and upgrade controls or something, But every job we go into, it is all about controls rather than just changing the boiler. It's like buying a brand new car and keeping an old engine in the car. What's the point in that, And that's the thing I always say to customers. There's no point buying yourself a nice, new, efficient, A-rated boiler and then keeping these old basic controls on it, because it's only going to work as well as how it's controlled. And if you spend a wee bit of time and actually put that forward to customers, they get on board with it and they're like, yep, that's fine, I'll be guided by you. But unfortunately, you will still get the odd one who, when the price comes through, they say, well, can we drop that off? Can we do this? Can we do that? And I do try and stick to my guns a lot of the time. And if they don't want to get on board with that, I don't bother taking on the job, because boilers now come with 10-year, 12-year warranties. So I say, I'm here for this boiler's life. And if they don't want to get on board with me telling them how you should work it, it's not really something I want to get involved in, because you can guarantee a year down the line, whatever, they're going to be clipping and this, So I just, within reason, say to them, this is what you need to do. Like I was saying with the radiators, I go in and say, really, you could be changing your radiators, do this, do that. A lot of people won't have that in their budget, but I'll say, this is what you want to be doing, but let's do this, let's do the basics, let's change the boiler, let's change controls, let's do that. But this is your long term of your next step. Because some people have got radiators 40, 50-year-old, there's 3 boilers down the line from when that was fitted. Again, like I'm saying, an old engine, old car, new engine in it. It's just, they're not as aerodynamic as they are nowadays, etc. So I'm sure you understand. I don't need to keep going on about the engine in cars, but but yeah, as long as you explain it, as long as you spend a bit of time and explain it, one, you can get the job because you spend time in explaining it. And 2, it's all about saving money, which everyone wants now, so they can get on board with that as well.
I used to kick them all out, to be honest, Ryan.
Pardon?
So I used to kick them all out, to be honest, mate. So I used to go in with a plan. Do you know what I mean? Because you've got to go in with a plan, because otherwise, what's the point in being an engineer, isn't it? So
yeah,
you go in with a plan, and then the reality is the budget. Do you know what I mean? And like you said, they haven't got it in their budget or whatever, but it's just that kind of push, isn't it? You just got to try and push at it and then negotiate it out. Look, I'm doing this for you. If you want to get the maximum out of it, you've got to do these other bits and pieces. Otherwise, you're not going to benefit as much as you would if you do them,
No.
And yes, it's a tough one, but I think as it goes on, I think more and more people will come on board with it. But
definitely. Well, I think this time next year,
totally get what you say.
But this time next year, when the bills are to be up by about 1/3, that's when people will start to think, oh bugger, like, right, now we're going to have to start taking drastic action. But when I go into jobs, say to price someone, say I need a new boiler, when I go in, I don't say, what is your budget? Now, I know a lot of guys do that, but for me, that comes across, you're basically saying, well, how much can I squeeze out of you? So I'll just say to them, right, this is what you want. This is what you want to be doing. And then they can get a feel for, if you say you're changing radiators or your repipe, they can get a feel for where the price is going to go. And I can only say to them, this is what you want to do. If it's obviously one and the system's 50 needs completely repiped and started over, if they're not keen on that, nah, just forget it, you know, wasting my time here, you know. And it's sad to do that, you know. I don't like walking away from stuff, but
got to.
it's just going to cause you a hassle. They're just going to come back and say, this isn't working right, and you just think, well, this is what I told you, and then they ditch you and they go to somebody else. Somebody else comes in and think, oh, he's bashed this on here, so yeah, it's not worth it. But I think this time next year when the bills are up, even my wife said, what's our bills costing? So everybody's talking about it now.
Yeah.
But then, like Bradley said, the worst case scenario is if you don't get involved with these jobs, then you're just going to have a load of good installers working on good jobs, and then a load of bad installers, which is a tough word to say, but yeah, just doing the cheapest job possible. There's still going to be people that are going to do it. Yeah.
Like I was at a job just a few weeks ago, went in with a flow cup, started checking flow rates and stuff. Says, what are you doing? I'm just checking the flow rate, see what we can go for here, what flow rate you've got. They said the other guys that came in haven't done that. One guy spec'd a 38 kilowatt. You could only put in a 24 max because of the flow rates. You're just like, well, what's the point? Pointless, you know. But this is what you're up against. People think I'll just crash in the biggest one for the best hot water. But if you haven't got that flow rate, you ain't going to get it. That this is something that you are at customer's mercy. You know what I mean? They are guided by you. And unfortunately, there's a few guys out there who, yeah, just want to chuck something on the wall and never come back again.
But then that's the kind of point in it. What you would save not fitting that bigger boiler, money-wise, you could then invest in things like controls. You can invest in things like that, but people don't know about it.
Yeah, well, the one thing I think every boiler I do now gets new controls. Everybody's on board with that. The controls I find is not a difficult thing to push. Then radiator valves are very easy as well. It's amazing how many still don't have thermostats. I think that's like, it's crazy how many don't have it. But those two are the easy ones to push. They're an easy sell, really. It takes 5 minutes to explain why you're doing that. They're like, yeah, that's fine. You know, what's a thermostat cost? 15 quid, something like that. Twin pack, you know, set of radiator valves. Obviously standard house 7 radiators. It's not really going to break the bank. It is when you start talking about radiators, piping. That's when a pinch can hit people a wee bit more. But like I was saying, smaller steps, just insulating radiator valves, controls can make such a difference. And yeah, people are definitely getting more on board with that.
Jonathan, as a learner in like college and on your apprenticeship, are they teaching you things about balancing, design, setting up systems, modulation, all the stuff?
Not at the moment. Like we are on. Well, I'm in the first year, so we're on the basics of basics at the moment, like your basic hot water systems, cold water systems, pipe work. So yeah, we haven't really gone into anything balancing wise. I can't see myself doing it, to be honest. I don't think it'll be in the curriculum, if I'm being honest with what I've looked through the curriculum. I don't think they'll be going into detail about balancing or anything like that. But that's more down to our individual employees to teach us that when we're there. So I'm not too sure if that'd be different if I was in college over an apprenticeship, but yeah, so we do the balancing side of that I'm already doing, but a lot of the lads that I work with definitely wouldn't understand that. Wouldn't have a clue what I'm talking about.
Yeah, and that's the next generation, Richard, because I imagine that's not taught in schools and colleges. And then, so how do you guys learn? Do you have to educate yourselves? Do you have to go to manufacturers? Is it learning on the job? What's the kind of, yeah?
For me and my dad, even my dad, like he's been in the business for years. He says a lot of the time it's like Facebook's a brilliant tool now. There's plenty of forums that people talk about stuff. You can ask questions, different installers. There's YouTubers out there. There's quite a lot of plumbing and heating engineers that are actually on YouTube. Some of them have got some decent stuff, some of them not so much, but you've just got to filter through all this. There's so much information out there now, you've just got to filter through what you want. But yeah, I think for me, a lot of the things I've been doing with Claire, and that's taught me quite a bit about the balancing of the TRVs and even just the systems that we have, the controls that we have nowadays. See, my dad's always he's always fitted Honeywell for years, and now he's moved over. He's always been stuck to his ways, so it's nice for me to hear it from other engineers as well. So, because obviously my dad's got his way, we all have our own way. I might not find down the line that works for me necessarily. I might see a different company and that works better for me. So it's good to, I think these places are the best places to find out them kind of things, listening to other installers.
Yeah, Richard, what was your, because you train other installers about this sort of stuff, don't you? So you're finding a lot of them maybe didn't cover this when they did their training, or a lot of new guys are coming out or start finishing their apprenticeships, finishing their learning, and haven't yet been covered about the sort of stuff that in the next 5-10 years we are going to see a transition towards.
Yeah, nothing's being covered in great detail. So the big problem we have is that a lot of guys not bad at the jobs through their own problems or issues. It's just the fact that they're just not taught the like I said, concentration on the water systems, how you put systems together, things like that. But actually the finer details which make all the difference. Calculating of flow rates, calculating of heat loss calculations, big deal. If you don't know what the heat loss of that property is, how do you even set the pump speed? How do you, if you're doing a system boiler coming away from a system boiler, if you did a heat only boiler these days, right? How many people could do a heat only boiler? If you actually gave them a system heat only boiler and they had to spec the size of the pump correctly, spec the radiators correctly, spec all the pipe work correctly, right the way through the system, all the way, and do the complete design from start to finish, set it all up, balance everything, and get it all running right and in condensing mode and everything else. How many guys can actually do that? I always question, it's a tough one, isn't it? So, but the guys that we see, it's the same story from every guy we talk to, that there's just been that fundamental, whichever way they've come in, whether it's been through college or apprenticeship or whatever. The apprenticeships can sometimes be the worst because you kind of focus on the areas that you need to focus for that employer, and then you don't actually learn the bit. Although you've qualified, you've not actually learned all the finer detail of some other parts of the industry. But it just feels the same. I hope it will change, Joe, because it just feels the same stuff keeps getting missed through the colleges. Not enough concentration around how important it is to actually balance the system up, get the correct flow rates through the system, get the system operating correctly. Because it's funny, we just put a question out there: who knows what balancing is really? And not many people know. That's the thing. Everyone thinks it's just getting the heat around the system at the right place, the right time, and it kind of is, but there's a bit more to it than that. And condensing boilers were purposely designed for DT of 20 across the heat exchanger, and that was to try and get it back in condensing mode as much as we could. And the only way we can do that is real restriction on the flow rates through a heating system. And something went wrong along the way. Do you know what I mean? Something went really wrong, because a lot of the manufacturers out there have missed the trick with it. And I know Drayton are coming back on, and they're going to actually have self-balancing TRVs coming out shortly. And you'll be able to put these on, set the correct flow rate, get the pump speed somewhere, the pump pressure somewhere correct, and the system will run itself, and it will be balanced instantly. And there's something, having these tools and having these products that can actually help and make your life as an installer that much easier. And you literally go there, set them all up to the correct settings based on the output of the radiator and what DT you're trying to achieve across the system, and it will do it all for you. So, having products like that are going to really, really help. But yeah, I mean, it's shocking. It's funny, when I first started, we first started all this several years ago. So a few groups got set up. I was part of the initial guys going onto the groups way before some of the bigger forums are set up on Facebook and places like that now. And loads of people just thought DT20 was a myth. You know, getting a 20-degree differential across a heating system is a myth. Okay, and it's only a myth because, like Ryan said, when we go into a heating system and you put a boiler on there that needs DT20, but we've got radiators that are the wrong size for the rooms, the wrong output, things like that, it's always going to be difficult to get the right output out of them because they're relying on a higher mean water temperature. And because they're relying on a higher mean water temperature, there's only two ways to achieve that. You either have a flow rate in, which is significantly faster than it should be, or you have to have a hotter temperature into the radiator and then a bigger differential. So one or the other raises the mean water temperature, and that's the big issue, and that's the reason why we always struggle to get that DC20 across heating systems, is because the radiators are a significant part of that, and we just haven't got the radiators and the flow rates and all the correct bits and pieces you need to get that all operating correctly. It's not there, and then you struggle because, like, some boilers don't even have adjustable pump speeds on them. So when the boiler pumps don't adjust and they're just flat out one speed, you're always going to struggle. You're always at a loser. So I feel sorry for, you know what I mean? I do feel sorry for a lot of guys out there because, like, it's a lot harder than it needs to be. That's a reality. That's the truth, mate. We saw it on the IMI day. How many issues did we have there on that day? You know, I know it was a bit of a prototype day we went to, and we were, you know, but the guys they're saying it's the same conversations, wasn't it? It doesn't matter what manufacturer it is or what place it is. The same conversations happen each time, don't they? You know, and they were really advanced guys there, but the same things, the same conversations around balancing, getting things right, getting the right flow rates. It happens all the time, and all the same things come up about, you know, just not having all the products that, you know, the guys need to do their jobs properly. And, you know, that's where manufacturers can come in and really help these guys. You know, if you design, like Ryan said, new boiler being released, if you're releasing a new boiler, make sure the pump can be adjusted, make sure that it can be range rated, it can be set up properly, has a low modulation ratio, so that, you know, modulates right down to like a kilowatt or something like that. Do you know what I mean? It really help us out, because what's the point in just making another boiler that then only modulates to 5 kilowatts when the property has only got 5 kilowatt heat loss? There's no point, is there? You know, if you're going to manufacture something that's going to be useful to all the installers that are going to fit it.
Yeah, Bradley, so when, like we said, we've got new products coming out, there's new techniques, there's new training and stuff. How do you know, how do you find out about these products? How do you make sure that you're kind of up to speed, and then you can then educate the consumers of the right kind of stuff for the job?
Well, to be honest, my college tutor's quite good, to be fair. He always keeps in contact and stuff like that. He goes to quite a few events. He goes to, you know, like all the events where they're showing all the new stuff coming out. But other than that, it's like you say, Facebook, Instagram, Twitter, you know, they're massive things now, especially people my age, you know, where, you know, a lot of people are always on the phones, you know. Instagram, there's loads of plumbing Instagram pages out there, and some of them are so, like, useful and handy to look at just for, like, the basics, you know, balancing systems. It's a big thing, and not a lot. Like, I know I went through my level 2 for college, and I was in 4 days a week, and you learn the basics, soldering, stuff like that, but you don't learn the nitty gritty. You don't learn balancing. You don't learn stuff. I never really learned what a TRV actually does. Like, everyone knows it turns up and down, but you don't know the actual nitty gritty. You don't learn the little bits and bobs. But other than that, the way you're pretty much, like, as soon as you leave college, you just got to put your trust into the people you're working with. You've got to put your trust into hoping that they know what they're actually doing. But if you've got people who are being taught by people who don't know what they're doing or something like that, then it's just never going to work out correctly. But but now there's not really that many excuses. Like you go on to social media, you see people flushing out systems, and a lot of people do not flush out systems, and it should be a thing that happens every time you fit a new boiler or a new radiator, anything. It should be flushed out. Like, and like there's so many new technique, there's so many things you can do, like the power flushes, the magna cleanse, you know, mains flushes, everything. You know, a lot of things are new, but they should be done. And I think social media is very good for, you know, finding new things to do and stuff like that. Yeah.